Hey everyone, in our previous video, we discussed how to use k-nearest neighbor for classification and regression. We discussed how to calculate the distance between the data points using Euclidean distance and Manhattan distance, how to assign weights to our data points, how to predict values for regression, one versus one approach and one versus all approach. So in this video, let's have a look at the parameters of KNN from the official scikit-learn's page. So this is the official website of scikit-learn's page where we can see the documentation of all the machine learning models that they have built. So here we can see the parameters. So the first parameter is n neighbors. So n neighbors is nothing but the value of k that we discussed, and we also saw the methods to find the optimal value of k. So this is the first parameter, and we can also see the weights parameter. We can also assign weights from here. The uniform parameter represents equal weights for all the data points, and distance, which is inversely proportional to weight. This is also a particular parameter we can assign, and we can also assign manual weights. There's a specific parameter called algorithm to calculate the distance between the data points. The scikit-learn will not directly use the distance to calculate the distance between every data point. Here, scikit-learn will use certain algorithms to calculate the nearest neighbors from the query point. These algorithms are ball tree algorithm and KD algorithm. These two are particular algorithms that can be used to find the nearest neighbor in an efficient way. Brute force is a particular method where the model calculates the distance between all the data points with the query point. Auto option will enable us to automatically decide which algorithm will be best suited for our model according to the dataset that we have. So let's discuss about the ball tree in depth in this video. Leaf size is a particular parameter that will be used while assigning KD tree or ball tree algorithms. So let's discuss about the leaf size later in the video. And this p-value decides which type of distance metric that we are going to use. Either we are going to use Euclidean distance or Manhattan distance. For that specific purpose, we can give the value for p here. And metric is used to assign the Minkowski value. From here, we can assign the value of p, and that decides which particular distance metric that we are going to use in the specific model. And the end jobs is used for the number of processors that we are going to run in parallel. So now let's look into ball tree algorithm and how it works. In k-nearest neighbor algorithm, the ball tree parameter organizes the data points in a hierarchical manner such that the data points are present such that it will be similar to a data structure like binary tree. In binary tree, we will be having parent node, child nodes and leaf nodes. In same way, in the ball tree algorithm, the data points are placed in a hierarchical manner such that it will be having root node, child node and leaf nodes. But the only difference here is in ball tree algorithm, the data points are placed in a higher dimensional plane. It may be either 2D, it may be 3D, 4D, etc. Here it will not be nodes, it will be spheres. So hence it got the name ball tree algorithm. This algorithm is efficient for higher dimensional data sets where there are multiple features, and the KD tree is used when the dataset has lower features. The ball tree algorithm is suitable when multiple features are present. It converts them into a higher dimensional space, and it calculates the distance between the data points from multiple features. So this is how a ball tree algorithm looks like. Here in this image you can see all these are data points. What ball tree does is that it first forms a superset where this particular sphere, black color sphere, contains all the data points. Then based on its centroid, it calculates the distance and forms subset of the data points. Like that, it will be recursively forming subsets of the data points based on distance. And finally, we will be able to get the leaf nodes where the leaf node represents the individual data points in a particular region. So if a new query point comes, based on these subsets or spheres, we will be able to calculate the nearest neighbors. So this is how the ball tree algorithm works in hyperplane, and this is the simplified version where it looks like a tree. Here C0 is the set which contains the entire data points, and C1 is the subset which contains another two subsets C3 and C4, which contains respective data points P0, P1, P2, etc. So this is the hierarchical manner by which ball tree algorithm organizes the data points. So let's consider an example here. So consider you have data points like, so what ball tree algorithm initially does is that it identifies a random data point. So consider it identifies the random data point. So what it does is that it first identifies the farthest point from this data point. So this is the first farthest data point, and it identifies the second farthest data point. So this is the second farthest data point. So what it does is that it joins these particular two lines. It joins these two lines. So with this distance, with this particular distance, it draws a circle with this as diameter. So this particular line will be the diameter of that specific circle. So consider this example, it will be looking something like this. If we draw a circle with that as diameter, it will be like this. So what here we have done is that we have created a superset for all the data points. So I am considering this as A. So we have created the parent node. So A will be the parent node here. So again, what it does is that it identifies the center of this particular circle that we draw. Since this is a high dimensional plane, consider this data points and this sphere in a high dimensional plane. So this will be a sphere. So we have to find the center of the sphere. It will find the center of the sphere. Consider this to be the center of the sphere. So now it will calculate again the farthest point. This point will be the farthest point, and this will be the second farthest point. So with these two as the diameter, with these two distances as the diameter, now it will again draw respective spheres. It will organize these data points in separate spheres now. So it will be like this. It will be something like this. So again, recursively, it will find the center of these particular spheres. It will find the centroids of these two particular spheres, and again it will try to draw another spheres, another subsets within these spheres. So we will be getting something like this. So we will be getting the subsets of all the data points. So consider this sphere to be B, and this sphere to be C, D, E, F, and G. So our tree will be something like that. A will be having the subsets B and C, and B will be having the subsets D and E. So this is how the ball tree algorithm organizes the data hierarchically. This contains F and G. So what happens if data points come here? If our new query point, is present here. So what it does is that it will find the distance between the centroids of the two spheres that is belonging to this particular subset B. Since the query point is inside B, it will find the distance between the centroids of these two particular subsets. If it will calculate the distance between this, and it will calculate the distance between this centroid. So it will identify which centroid is the closest. Let us consider the centroid E is this closest. So it will calculate the distance between this particular data point and this particular data point, either using Euclidean distance or Manhattan distance or anything. Like this way, we will be finding the first two nearest data points from the new query point. So this is what happens in the hyperplane. In the tree structure, it will be forming depth first search approach. So it will, from the parent node A, it will be coming to this particular node B. From this node, either it will come to node D or E. First it will check the distance between node D, and then it will check the distance between node E. If the distance between node E is less, then it will add the new query point to this particular node. So this is how the query point is classified in ball tree algorithm. So what happens if the query point is inside this node A? It will first classify the distance between these two nodes. It will first identify the distance between the centroids of the node B and C. If the centroid of C is nearer to the query point, then it will identify the centroids of F and G nodes. If the centroid of F is near, then it will identify the first three data points which are nearer to the query point. So recursively, this will be happening again and again until the n nearest neighbor or the k nearest neighbor. The value of k will be defined in another parameter. So the required number of nearest parameters will be obtained by this method. So I hope you understand how the ball tree algorithm works.
You can always check this official website of scikit-learn to know more about the machine learning models. Feel free to check this website. So that's all for this video. See you in the next video.